The fundamental theorem of algebra. This is basically putting together everything we've been doing and using to solve polynomial equations. This is how you solve the higher order polynomial equations that you cannot factor. The main concept in this whole video is quite simple. Whatever the degree of the polynomial is, there are that many roots. And the polynomial can be factored into that many factors, each starting with x, linear factors. Now when we start talking about with all these different terms, zeros and roots, well, zeros are roots of a polynomial, but roots aren't necessarily zeros. If the root is an imaginary root, then it's not a zero. We've already learned the rational root theorem. We've been using the factor theorem for a while. We've learned division and the quadratic formula. And basically, every problem we do, we might use some of this one, we might use all of it to solve a problem. But basically, you need to be able to use everything we've learned so far to solve these equations. They always start off the same way. Set one side equal to 0. Then if you can factor it, factor it. But if you can't, then we have some different ways. We're just going to start looking for rational roots, all sorts of different ways. So here's just an example. State the number of complex roots, the possible number of real roots, imaginary roots, the possible number of positive and the possible number of negative roots, list the possible rational roots, and find the roots for this function. That is a lot of stuff for one function. You should be able to do all of this, and a lot of it's simple, but there's a lot of steps. What is a complex root? Well, that is just basically any kind of root. So a complex root could include imaginary roots, irrational roots, real roots, but it's real simple. Whatever the biggest exponent is how many complex roots there are. Since this one has a 5, there are 5 roots, 5 complex roots. A possible number of real roots. So there could be as many as 5 roots. They might all be real numbers. But if there's a root that's not a real number, it's an imaginary number, and since they come in pairs, there would either be 5 or 3 or 1. And now we're going to do a number of imaginary roots. Again, they come in pairs, so there might not be any imaginary roots, but if there's a pair, then there's 2. If there's another pair, then there's 4. But there's a max of 5, so it could be 0, 2, or 4. Possible number of positive real roots. This is simple. Count the number of sign changes. 1, 2, 3, 4. I see 4 sign changes, so there are 4 or 2 or 0. You go down by 2 when you count the number of possible positive real roots. To get the number of negative real roots, we need to determine what is f of negative x. So everywhere there's an x, we're going to put negative x in parentheses and simplify, and then count the sign changes. I see 1 sign change. That means that there is 1 negative real root. And since it's 1 and only 1, there must be 1. So as I'm trying to find my answers, if I find a negative root, I'll quit looking at negative numbers because there's only 1. That's all that tells you. Gives you a hint when you're finding the roots of how many there might be of the different kinds. What are the possible rational roots? This is where you take all the factors of the constant, the 6, divided by all the possible factors of 1, and it's plus or minus. So it's plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, all divided by 1, since 1 is the only factor of the leading coefficient. Now find the roots. So now we're going to take the different roots. We're going to start with the easiest one, 1, and plug them in and see if we get 0. If we plug it in and get 0, then we're going to divide with that factor and find the new polynomial and keep going until we get it completely factored. So if we find f of 1, plug 1 in for x. Do we get 0? Yes, we do. So 1 is a root. So I need to divide this thing by x minus 1, because that's what the factor would be to give us 1 for a root. So using synthetic division, since 1 is the root, I'm going to put 1 in the box, bring it down, divide, and there's my new polynomial. The answer is x to the 4th minus x to the 3rd minus x squared plus 7x minus 6. Now you're going to take that new polynomial and plug in 1, 2, 3, 6 plus or minus and find, see if there's another 0. If we plug 1 in again, it is also a 0. And we divide again, and we get a new polynomial. We get x cubed minus x plus 6. There's a 0 in there, so I skip squared. Then we tried other numbers, and we find a -2 also works. So I divide with the -2 in the box. I get x squared minus 2x plus 3 is my final answer. Now use a quadratic formula to find the two more roots. And what we'll see is we're going to get some imaginary numbers when we plug in a is 1, b is -2, and 3c into the quadratic formula. And then we'll end up having all 5 of our roots. Now there was a lot of stuff in that. It's just going to be one example, but there's a lot of different steps. So we have 1 twice as roots, -2, 1 plus I square root 2, 1 minus I square root 2 are our 5 roots. And if I wanted to write that polynomial in factored form, you see it there, x minus 1 squared times x plus 2 times x minus the quantity of 1 plus I square root 2 times x minus 1 I square root 2.